is an article I wrote for Bag Magazine 23 years ago. And I probably received, I've published about 150 articles over the years, mostly back in the 80s and 90s, mostly for either computing magazines or gaming magazines writing on computers and gaming. I received more feedback on this article than any other single article I've ever written. And this is the days where most people didn't have email. So I was getting actual physical letters on this. And almost all of them said, thank you for saying this because no one seems to believe this. There are inherent or natural talents in information technology, and as I talk about in the next article we'll get to, it's not a you have it or you don't, and it's not a single talent. There are a variety of talents, and there's a variety of scales on them. But there is, and has been over the past 40, almost probably 50 years, I'm trying to think when the oldest studies were, performances that show variations in productivity among software developers. The highest figure you'll see cited is 26 to 1. I'm not sure who the 1 was. But ostensibly, these studies were controlled for education, background, experience, and so on. Most studies you'll see are on the order of 5 to 1 or 10 to 1. And I've noticed just in the last year or two, 10x has suddenly become this buzzword that I see popping up everywhere. How do you find and hire a 10x programmer? It's a 10x meaning someone who's 10 times better than anyone else.
Oh.
So if you do a Google on 10x developer, you're going to get a lot of Google hits. Yes?
So these are comparisons of the least productive software developer versus the most productive software developer in a company? Or?
Generally speaking, yes.
I'm just trying to figure out what was being compared exactly.
Yeah. Typically, these studies have been, here is a problem, and they have the set of developers all work independently in the problem. They see how quickly they got it done, what kind of defects they had, how efficient their solution was, and so on and so forth. But there are people who are really good and there are people who aren't. I think my own first discovery of this was actually as a CS undergrad here at BYU. I have a roommate who was a business major, and he had to take, as part of his business major, had to take this, it's like an introduction to programming in COBOL class. It was a very simple class. And he came to me, obviously, as his roommate, and as, the resident geek for help. And I was sort of startled. I mean, I was still just in my first year of computer science because I got married a year after I got back from my mission. I was still in my first year. And it struck me that things that seemed utterly simple and obvious to me, he had a very hard time grasping. It's kind of like, well, why do you do this? Well, you do it because this is how this works. Well, why does it work that way? And that was sort of my first clue. My second clue came, as I mentioned in the article, when I graduated, went off, worked for a few years, moved back to BYU about 7 years? Yeah, 7 years after I graduated. Moved back up here to Provo, and the department found out, I think I've already mentioned this, the department found out I'd moved into the area and said, oh, we'd love to have you come teach. And I was so flattered. Then I discovered it's because the enrollment had climbed from 120 to 1,000. Yeah, 1,000 CS undergrads. If you go and look, and this was nationwide. If you go and do searches on computer science degrees granted or enrollments, you will see this enormous peak right at 1985. And then it slumps down, and then it peaks again at 2000 because of the dot-com boom. Then it slumps down again because of the dot-com crash. And then it's been sort of climbing ever since, but at a slower rate. Anyway, so I started teaching. I was having a great time, enjoyed it. And I happened to be talking to Gordon Stokes, who was my former faculty advisor when I was an undergrad. And I was marveling at the growth of enrollment. It was 8-fold growth in enrollment in the space of 7 years. And Gordon sort of said, yeah, he says, but here's my observation. the number of really excellent students is still the same. Not the percentage, the absolute number of really excellent students is still the same. You had a vast number of people signing up for computer science because they were sure, when I was an undergrad, everyone wanted to go into medicine or law. It was kind of like, yeah, you get through med school, you get to law school, and you're financially set for life. It's not quite that way anymore. But back, 40 years ago, almost 50, I'm old. That was it. Well, they saw programming as the next big way to score. All you have to do is learn how to program, and you'll start a company and you'll be rich. And it was sucking a lot of people who had no particular aptitude for computer science and software development. And it's the reason why you see this peak in 1985 and then you see this enormous drop-off. Because a lot of people suddenly discovered, I'm not very good at this. I went through this a bit myself with music. I'll spare you the whole story about how I ended up with choir in high school, but I really liked it. Even though I had no musical, frankly, I had no musical talent. But I did actually learn through sheer effort. Choir was my single hardest class in all of high school. It was frankly harder than football. And so I got up to BYU and I thought, I'll sign up for a music theory class because I've never had music theory. And I dropped it in like 2 weeks. I thought, this is bizarre. This is not sticking on my brain at all. And I'm the math science geek. I've got all this, and I'm sitting here in this music theory class and saying, okay, I'm dropping this. This is going off my schedule right now because I'm not any good at this. I find it interesting that we perfectly accept that people are gifted in math, in art, in athletics, in various other areas. But there's sort of this resistance on some level to saying, yeah, some people are naturally gifted at software development, others aren't. And beyond that, there is a broader general aptitude. Some people get it, some people won't. It's why and you'll hear me say this, I roll my eyes when I hear of all these initiatives to, we need to get more people coding. It's like, no, we actually need to get less people coding. I was going to say the third thing, which actually was not long after the first thing. I took CS404. It's called Computers in Society back then, and it was being team taught by Tad Norman, who was a former department chair. And I probably still have my notes somewhere. I saved everything. He was team teaching with another gentleman who had worked, like me, had worked in industry for like 20 years and was taking a year off just to teach and relax. And this professor who was, this industry guy who was helping to teach the class was talking about the issue of qualification and certification and things like that, and he said, if you knew which ones to pick, you could take half of all the people currently working in data processing, which is what they called information technology back then. You could take half of all the people working in data processing out and shoot them. And he said not only would no deadlines be missed, but a lot would be advanced. I thought, boy, that's cold. And then I graduated and went to work and thought, oh, he wasn't exaggerating at all. I found myself dealing with code and saying, how can someone who's working full-time as a software engineer write code this incredibly bad? And we'll talk about this in a later lecture, but it's a real challenge for people who are hiring engineers to figure out how to hire someone who's really good and really qualified, will work out well, will fit in. We'll have a whole lecture on that issue. But the problem is, of course, the demand for IT greatly outstrips the supply of inherently talented people. So it's this giant sucking sound, sucking lots and lots of people who can get jobs and work at IT. How many of you have had an experience where you've hand already goes up. where there is a coworker or someone in a place where you're working and you find yourself wondering, how did that person get hired as a programmer? Oh yeah, like, well, you know, look guys, right there. So, anyone want to share any particular experiences with names filed off?
Yeah, no names. But I had a coworker that she put up a code review, and I kind of looked through it and I was suspicious that it didn't run. So I asked her like, hey, did you count for this? She's like, oh, I didn't think about that, and then fixed it. And just because I was now paranoid, I ran it, and it didn't even come close to doing anything it was supposed to do. And she must have never run it in order to think that it worked, and just posted it up. So I kind of gently guided her back towards the actual problem.
Actually getting to work. Anyone else want to? You're all being kind. Oh yes.
I've had a classmate that got hired from Microsoft as an intern and didn't understand how to do anything in our classes to put a class together. She's like, how did you get hired as an intern?
Well, that's a whole nother question. Now, this is what I wrote in 1996. I then wrote a blog post in 2008 saying, okay, I've spent years working in here. I've built engineering teams from scratch. I've screened consultants to put into client sites. And here are the factors that I now consider important. First, talent. It's not a single talent, and it's not a single you have it or you don't. I sort of liken it to D&D. There's a set of talents, and you do a 3d6 roll, and you get sort of a bell curve. It really is sort of like that, and there are different talents. I've seen people who are outstanding at just writing pure code, but maybe struggle with tracking down bugs or struggle with architecture. You know, I've seen people who are greatly talented on all levels. And I'll note here, because education is up there, this doesn't always correlate with education. At Pages, where I built an engineering team, about 10 people, the two best developers there did not have college degrees. One of them only had a GED and was like 22 years old. And was writing object-oriented operating systems in his spare time as a 22-year-old. This is back in like 1990, 91. So it really, you know, you do have talent, but talent isn't everything, and it isn't the only thing. Experience. When I'm hiring, I look for people who have actually been through the grinder, particularly who've been through troubled or failed projects. You'll hear me say this a number of times. At Pages, we were a year late in shipping. And as the chief technical officer and chief software architect, I was one of the 2 or 3 people who had to go to the investors every month and tell them why we were missing our current deadline and why they should believe our new deadline. It was the single most painful professional experience of my life. It made me question everything I thought I knew about project management. I wrote 2 books as a result, The Art of Where and Pitfalls of Object-Oriented Development. And within, basically immediately after the company folded, started my consulting career going in and advising companies with troubled projects. And saying, here are the problems, because I know them firsthand. Here's what you're doing, here's what's going to fail. So, experience is important. Professionalism. Now, DeMarco and Lister, Peopleware will talk about professionalism in a negative point, but what they're talking about are things like dress code. You know, and I've worked in environments. I worked at PricewaterhouseCoopers, had to wear slacks and a nice shirt, and, you know, look nice every day. Professionalism for me is showing up and doing your work, not causing problems. That's professionalism. And I've worked in situations where we've had developers who had very unprofessional behavior, and it was very disruptive to the rest of the team. Education. This is a constant debate. Do I really need a CS degree to be a software engineer? No, but it helps a lot. I sort of dealt with that same issue And then I graduated, went to work at General Dynamics, and immediately found that my knowledge of a number of fundamentals of computer science, including data structures, including algorithms, including various things, including exposure to multiple programming languages while I was an undergrad, was a tremendous advantage. And I would look at problems and say, well, yeah, you can do this, this, and this. And of course, this is back in an era where the dominant side, I was all in scientific / engineering programming. Dominant language was Fortran. Fortran had exactly one data structure, arrays. That was it. You used arrays for everything. You used arrays for records, you used them for strings, you used it for any kind of data structure you wanted to build. But I understood all the various options for data structures, and I knew how to build linked lists with arrays, and I knew how to build queues with arrays. I knew how to do very fast sorting on arrays. So, education, while like I said, you know, two of the best programs ever hired. One was this GED kid who at Pages, I ended up, the last year there, I basically turned over the software architecture to him. He understood it better than any of the other developers. He was the only one who came back to me and said, you know, if you change this, you could do this. And I said, oh my gosh, you're right. So he was making active suggestions to improve the architecture of this desktop publishing system. The other, who's still one of my absolute best friends, Bruce Henderson, went to college for a few years, loved his programming classes, hated everything else, dropped out of college, joined the Marines for a couple of years, where he's doing avionics and doing programming on his own, and then went on and has been extremely successful as a software engineer architect. Skills. Now skills, ironically, this is sort of what HR tends to look for. Do you have a certification in X? And they do that because it's easy. When I was hiring for Pages, we were developing for the Next Step operating system. There was almost no one who had any experience with Next Step. Or with Objective-C, which was the primary language for Next Step. For those who don't know, Next Step eventually evolved into Mac OS X. Apple bought up Next in 1996 because Apple had tried 2 or 3 different times to do a new operating system and it failed each time. So they finally bought Next, and then within a year, Steve Jobs had managed to nudge out the existing CEO of Apple, Gil Amelio, and took over. But you know, back in 1990, when I was starting to build the engineering team, there was basically, Bruce Henderson actually had Next Step development experience. There was no one else I hired who had any Next Step development experience. But they were all great software engineers, so you know what? Here are the manuals. Go learn this. Any observations, feedback, questions on these aspects? How have you seen this in your own experience today? Yes?
Well, I'm just looking at experience, and I'm thinking of that meme with the 2 people yelling at each other about you need experience to get hired, but you need to be hired in order to get experience.
And that's a real problem. It's not breathe my Coke. It is a real problem, and it's a generic problem in job hunting anyway. Without going too far afield, the reason I hired Peter Linz, who was this 23-year-old with a GED, is because I had hired another software engineer, Rick Gessner, through a recruiter. And when Rick Gessner came on board, he came to me and said, Bruce, there's this young guy back in Arizona that you really need to bring in to hire. He says, I know his resume isn't going to look like anything, but he's the single brightest developer I've ever had. And we brought him in, and we all interviewed him and said, yeah, we're hiring him. It turned out to be absolutely outstanding. Which leads me to something we'll talk about more on another time, but In my experience, the single best predictor of whether or not someone you're trying to hire is going to do well is the opinion of someone whose opinion you trust. And it's a real dilemma, because it's basically, it's why networking is so important, but you really need someone to say, yeah, I've worked with this person. She's great. Hire her. And absent that, you've got to figure out a way to sort of get the same effect. And we'll talk about hiring in a later lecture. The Dead Sea effect. I observed this while consulting at Fannie Mae about 23 years ago. I was with Object Systems Group. We had like 25 consultants in there helping with a number of software development projects at Fannie Mae. And Fannie Mae had its own in-house software developers. And I kept noticing over the 2 years I was there, all the best software developers working at Fannie Mae kept leaving. And as this happened, the overall quality of their in-house software development group was steadily declining. And since then, I've observed this in a number of organizations. If the organization fails to keep its best people happy, they will leave. They will leave because, first, they don't have to put up with it. They usually find a job somewhere else. Second, they're getting offers. And third, they're frustrated. Now, this doesn't happen in every organization. Some organizations are just, as I said in the article, just the opposite. They do a very good job of hiring good people and chasing away people who aren't as good, who manage to get in anyway. Have any of you ever observed this? Most of you probably haven't worked at places long enough to see this happen. Yeah?
Yeah, just working at the MTC's IT department.
Oh.
Their management changed, and I noticed everyone I respected on my team left, and then I left a month later.
Yeah. Yeah. It's very real syndrome, and it can bring down an IT shop so quickly. Bring down the quality. Now, the people who are there usually can entrench themselves. In other words, they're the ones who are left. They know the systems. They know, to a certain extent, the code. And so management will have a hard time sort of replacing them because they sort of like a tick. They sort of burrow in and, you know, they're stuck there. Yes?
We had something happen in my company where one of the head engineers kind of had everyone else like flocking around him. And so he decided that he had had enough of the company and left, and everyone else left with him. And so we lost an entire department in like a day.
Yeah.
And we had to like try to pick ourselves up out of the...
This is a real problem. It's not unique to IT, and it's not true of all organizations. And everyone left behind isn't necessarily incompetent. There are people who will stay for a variety of reasons. You know, they own a house. They have kids in school. They don't want to relocate to where, you know, better opportunity may be. But if you're not careful from a management perspective, you can end up driving your best people away. And by so doing, significantly drop the quality of the work that's being done. And significantly increase the time it takes to get any work done. The surgical team, this is Mythical Man Month. Fred Brooks talks about the same issue, the variation in productivity among developers. By the way, I've been programming for 45 years. I've, been gone from BYU for 41 years. I focus a lot, I write a lot on software engineering and project management. And almost every time that I think I have some new insight, some great, my gosh, this is new, this is a great insight, I can go back to Mythical Man Month and usually find that Fred Brooks stated it somewhere in the book, like 40 years ago. There's a reason why this is the book that I want you to read, because not only is what he says saying true, it is held up over 40 years. He talks about the 5 to 1 to 10 to 1. He says, well then, why don't you just keep the best programmers and fire everyone else? He says, well, some big projects, and he worked on very big projects, operating systems for mainframes. You can't do that with a small team. So he talks about how do you organize teams within a big project to be effective. And he says what you do is you get the best people as the lead, as a surgeon, as the lead programmer, and build a team around her or him to take all the busy work off their shoulders, to make it faster. So this is a lot of what he talks about as far as actual roles are more archaic now, because he's talking about a lot of things. You don't, I mean, I date back to the era where you used to have like manuals for systems that were like, 2 or 3 feet of shelf space, and you would flip through and use indices and try to find out what things are. A lot of this is now, replaced by Stack Overflow. But a lot of it is replaced by websites, by online manuals. I mean, when was the last time you bought software that had an actual physical manual that was anything other than a quick start guide? In fact, when was the last time you bought physical software? As opposed to simply downloading software or an app. I found it absolutely fascinating over the years to see the shift from back when I was doing Sundog and the word plus, so we're talking early 80s, where the company would do its own shrink wrapping and mail stuff out and so on. You had, computer stores were relatively rare, and then you went to the big era, particularly when CD-ROMs came out, the big era of, Best Buy and places like that where you have, racks and racks of software, and now that's all shrunk down. You go in to look at software, and it's like, oh yeah, there's about 6 feet maybe of space here, and it's the same 2 dozen programs that you always see there. Any comments or thoughts having read this? I assume you read it. Everyone's like, no, move on. Okay. Okay, Peopleware Chapter 2. Now, next, oh yes.
I actually did have a question on the previous slide. So he talks about the chief surgeon, and then I can't remember the name, but like the helper to the
Yeah.
chief surgeon, right?
Co-pilot or whatever,
Yeah,
mixing metaphors.
So those are like the 2 main developers, right? Are the other helpers, do they do any actual like programming, or are they just there as resources?
Well, actually, as he describes it, they're mostly there as resources. But it's a sort of work that now is largely supplanted by software. So you have someone as a librarian, whereas now you just get, go buy some or download some open source configuration management software. You have someone doing documentation. Nowadays, you probably have someone running, an in-house website or SharePoint or whatever, and compiling documents there. So a lot of the roles he has are now replaced with electronic network equivalents. Yeah.
Do you have like maybe an updated surgical team kind of layout for us?
That's actually a good question. No, I don't, but I'll think about that, and that may well be worth doing. This is actually a chapter which I've ignored in past semesters, but I was looking through it again because I was trying to reorganize the lectures by topic, and I thought, this is still worthwhile. It's still got some good information, but your question is a good one. How do you do the equivalent? There's a slight hint here of pair programming too, because he talks about having 2 developers, but he says one of them has to be the decision maker. Because one of the biggest problems you find is well, I want to do X, well, I think Y is better, and you get into a deadlock between, programmers butting heads, and someone has to step in and say, okay, we're doing X. This will be, when we talk about architects and project managers, this will be a big issue. as to why those two have to be separate and why you want a chief software architect. Okay, these next few chapters talk more about the management environment for programmers to work in. We'll talk about that a lot, but here we have the problem that managers, how many of you identify with this? Managers see development like making fast food. Oh man, it's been this way forever. It's like, well, you just hire more developers, you know, Brooks Law. Adding people to a late project makes it later. It's like they think it's an industrial mindset. It is not an intellectual mindset. And management tends to see developers as interchangeable and scalable. And software development is not that way. It is highly intellectual. It is highly creative. We're back now to both Armor and Brooks Chapter 1. It's intensively intellectual, it's intensively creative, it's intensively discovery. And to try and take a ditch digging, you know, infinite number of ditch diggers approach to software management just doesn't work. What's interesting is there have been attempts over the years to actually do the same thing to software itself. There was a big movement back in the 90s, particularly with the advent of object-oriented development. This big advent to software components. You'll have all these software components, and you'll have heavy reuse, so you'll only develop, you know, your sorting algorithm once, and you'll plug them all in together. And you can just build software by putting components together. And this concept still underlies a lot of the AI hype over AI programming. Artificial intelligence will make us all obsolete. Well, you know, like I said, I've been hearing it for 40 years. Could happen, I doubt it. Because you have the discovery and creativity issues. So we have the attitude that management provides the thinking and the people underneath just carry out their bidding. Here's how I want you to code this. Well, it doesn't work that way. Well, that's what I want you to do. But this will happen, but that's what I want you to do. Have any of you had that experience of having management say, do it this way, and you know full well it's not going to work that way? Anyone want to share anything here? Anyone? Yeah.
This didn't happen to me, but it happened to my manager. He was working for a place, and he noticed that there was an edge case that wasn't being handled. And he brought it up to the architect, and the architect was like, that will never be hit. That's never going to be a problem. And my manager was like, it will be a problem for sure. And he was like, you know, the guy got really riled up about it. So my manager put, as the error message to be thrown if it ever got hit, call this number. And he put the personal number of the guy. And lo and behold, when they released it, the guy got called multiple times by customers. And
anyone see the XKCD comic that was just, I think, just this past week? The error message says, this is supposed to be unreachable. If you're seeing this message, I truly, deeply apologize. This was never supposed to happen, and obviously I didn't think this through. Yes.
That just reminded me, because that just recently happened in the lab I was working at. There's some old software that started having some errors because we were trying to update something, and there's all these error messages that are like, this should never happen.
Yeah.
If you've seen this, something has gone wrong.
Which is a great error message to put in. And I admire particularly the manager pushing back against the architect. The architect should never say, oh, that can never happen. That's obviously an architect who just doesn't have enough experience to realize how badly things can get. And part of the problem with software is that, I mean, it's a different era. When I did Sundog on the Apple II, 64K of RAM, I knew the entire memory map. I knew what was happening in every byte of memory there. I managed it very carefully. I hacked the P-code interpreter. I wrote all my graphics libraries from scratch and everything else, and I was very carefully managing down to the byte level how much memory there was. You work on systems now, you know, 16, 32 gigs of RAM. You pull up services and you've got like 300 services that are running. How do you know what's happening? How do you have literally you have a state space that makes the universe look small. You really do. Number of possible states on that system make the universe look small. And it's a tremendous quality assurance challenge. Now, last year here for us. We as developers are often too busy sawing to sharpen the saw, and DeMarco and Lister say that the average software developer doesn't own a single book on the subject of his or her work and hasn't ever read one. That's true. One of my first my first consulting gig was at Airing, and I was in there mostly to help because they were switching to object-oriented development and they were doing it all wrong. And it had a disastrous design review. But there were project management issues as well. There are architectural issues. I'll come back to Airing a number of times. But I went to the vice president over this division in Newport Beach and said, can I have a budget to buy some books? He said, yeah, sure. So I bought 30 copies of Mythical Man Month and handed them out to everyone involved in this project, literally from the vice president over the division through all the levels of management, every single developer. And about 4 weeks later, I checked, and not a single person had read the book. This is the problem in the industry. It's why I have steady work as an expert witness for failed projects. Because the sources of the authorities I usually cite are from 30 or 40 years ago. It's like, yeah, we've known this for decades. I actually had, during cross-examination at a trial a few years ago on a failed SAP installation, I had the opposing lawyer say, well, Mr. Webster, wouldn't you agree that technology changes rapidly? So yeah, it changed very rapidly. He said, but isn't it true that this book you cite here, The Mythical Man Month, was written 40 years ago? I said, yeah. He said, so why are you relying on it? I said, because it's still true. It's still all the same errors. The fundamental issues are there. That's why you need to read this stuff. So at the very least, you can go in with eyes wide open. Any other feedback or comments on this before we move on? We're going to come back to this issue, but the sad thing is, 45 years after I started doing development, it's still true. A lot of management works on a heroic model of software development, which means you're working extra hours. Now, it's one thing to do it in a startup, which I've done. At Pages, I averaged probably 70 hours a week for the first 3.5 years. When we finally shipped, my reward to myself is I no longer came in on weekends. I have worked 100-hour weeks as a developer. I don't know how productive I was, but I have worked. Frankly, if I was doing it again, I might not work 100-hour weeks. But the point is that, and DeMarco and Lister will come back to this again and again, sustained overtime doesn't work. Their studies show that when you push developers, say, we need you here 60 hours a week, you know what happens? They still work 40 hours a week, and the other 20 hours a week are email, phone calls, hanging out in the hallway. Your brain can only take so much creative work. And then you start to burn out. I have burned out. I burned out finishing version 2.0 Sundog. I did not program for money for 4 years. I tried to, and I just couldn't do it. Because I basically did an anxiety, what you call now an anxiety attack. Fortunately, I had built up sort of a side of writing articles, and I was able to live off writing, teaching here at BYU, and some other things until I could finally go back and start programming again. It is very possible to burn out programming. And a lot of managers will just see it as, well, that's part of the cost. Well, he was getting kind of uppity. She wasn't coming in as much as she should. We're glad to see them go. And you lose your best people that way. You use them up. I recognize most of you are still young and tender here. Anyone have observations or experiences as far as compelled overtime or expectations of unrealistic development hours? Yes?
like working on the last year's video game project with the animation program, like it seemed like we had a couple of days near the end when we were trying to get things done for certain deadlines that were crunch time, right? Where we were there for basically, like, I wasn't there the whole time, but a bunch of people were there for like almost 24 hours straight and stuff like that. And one of the lead programmers like remarked like, if we had just like planned things out better earlier, then this would be unnecessary anyways. So
Now the irony here is that my undergraduate degree prepared me for this kind of work environment. When I was here at BYU, all the programming was on mainframes. You know, I submitted cards to the IUM 360 or was terminal-based programming on Index System 10, both mainframes. And what would happen is you'd sign up for a class like 232, algorithms and data structures, and you would have an account in your name for that class for $100, quote unquote, of computer time. And so when you'd log in with your account credentials for that class, and it would bill you by the hour. This was largely done to prevent people from spending time playing Star Trek on the mainframe or Adventure or whatever. But one of the things that the BYU Computing Services discovered was that demand was very high during the day, would start to drop off in the evening, and then would be, of course, near zero overnight. So they implemented a pricing schedule where after 6 p.m. you got like a 20% discount, and after midnight you got a 90% discount. And all of us in computer science started programming from midnight to 8 a.m. because you could do all your assignments and still have tons and tons of billable time left over for games on the system. and so quite literally the last couple of years I was here at BYU, I was very used to finding terminals either in what was then the Richards building, or there were terminal rooms in the Talmadge building, the Jesse Knight building, and a few other places, and going there at midnight, waiting for midnight, logging in and programming all night long, and logging off, 6, 7, 8 a.m. in the morning, and having used up a tiny fraction of my billable time for that class. That came in very handy. What I can tell you now is that nearly 50 years later, I can't go to bed before 11 o'clock. I just can't. If I go to bed before 11 o'clock, I wake up at 3 in the morning and I'm wide awake. So I go to bed between 11 and midnight every night, still, at this age. And I'm up between 6 and 7 each morning. So most of you, at some point in your career, you're going to be on a heroic project. You're going to be actually maybe on a death march. We'll talk about death marches at some point here. Okay, now from Accelerate, I assigned chapter 7, but it makes reference to these organizational cultural models. And so, some author named Westrom says there are basically 3 organizational cultural models, and then you'll see variants in all of these. But you have the pathological power order. Get low cooperation from management. People who bring bad news are shocked, they're criticized. Responsibilities are shirked. Working with other groups is discouraged. If you fail, people are scapegoated, and any attempt to do something new is crushed. There are real organizations like that. Some of you may have actually worked in organizations that are like that, or were a lot like that. Anyone? Anyone? No, you've been lucky so far. Then you have a bureaucratic or rule-oriented, where modest cooperation among different groups is encouraged. Messengers are mostly ignored. So you come up with bad news, and it's just go, yeah, thanks for sharing. It's been like the manager trying to tell the architect, no, there's an edge case here, and the architect's like, oh, no, it's never going to happen. I like that solution. Responsibilities are narrow. They allow you to talk to other people, but it's more toleration. If there's failure, then they tend to truly track down the guilty parties instead of who's convenient. and introducing something new leads to problems within the organization. Then you have a generative or performance-oriented, where cooperation is encouraged. Messengers are trained to bring bad news. Boy, we'll talk about one of the website articles you'll read later on is called the Thermocline of Truth, and it is so true. I mean, the phrase originates with me, but the concept's been around forever. And this is simply the concept that upper management doesn't like to hear bad news. I have an article on BFWA website, linked to an article where the Air Force had $1 billion accounting system reengineering project failed primarily because of the Thermocline of Truth. Upper management within the Pentagon, within the Air Force, did not want to hear the actual problems that were going on. And so the whole project dragged on for 7 years. It was canceled. Nothing came from it. They spent $1 billion on it. Risks are shared among groups. Bridging between groups is encouraged. Failure leads to inquiry. Postmortems. One of the most important things you can do with a troubled or failed project is a postmortem to find out why it went wrong. Organizations don't like to do that, usually because there are people on higher levels who don't want to realize that they are a part of the problem. And things that are new are implemented to try out to see whether or not they're useful. Now, chapter 7, which you were supposed to read, notes that lean management practices lead to the performance-oriented organization, less burnout, delivery performance. And what you really want is to take small bites, limit work in progress. As my friend Bruce Henderson likes to say, start out stupid and work up from there. And visual management so you can actually see what's happening. And then a lightweight change management process. And this is interesting because I've typically been a big fan of change management. And in Accelerate, they argue and say, our observation is that a formal change management process doesn't help. It just slows things down. And I've been willing to change my idea because they actually back their stuff up with research. They say a lightweight change management, which is kind of like, okay, we've got to decide, are we going to fix this bug? Do we have to change this feature? Are we going to add this? What's it going to cost? Something where a decision can be made very rapidly and without dragging a lot of people in is the best solution. And that's that lecture. Okay, we're right at the break when everyone else is going out there. Let me call roll, and then I may start into the next lecture, and once everyone else is back in class, we'll let you guys have the bathroom break. Do you have a question?
Yeah, I
comment?
actually had a couple questions.
Okay.
The first one was, it was a comment under the Tempest article, I believe.
Uh-huh.
That was like, did you actually interview, or did you actually
Oh,
review resumes
my
of
10-10-10 thing
Yeah.
in pages?
of 8,000 to 10,000 people in order to get those 10?
I probably looked through several thousand resumes during a year and a half that I was hiring pages. 10-10-10 is a nice rule of thumb now. And I would say you probably look at least 10 resumes before you find one you want to talk on the phone. If anything, that ratio is longer. It's probably a lower ratio for people that you talk to on the phone and bring in. But I'll say the 10 to 1 on looking at resume and deciding to call and bring in. 10 to 1 is probably very easy. Probably, if I try to get better or got better at bringing people in. So if we brought someone in, if we went to that time and expense, it was probably closer to a 4 to 5 to 1 people that we brought in. But yeah, I mean that's like 10 times 10 times 5 is looking at 500 resumes to find one to hire. So it's online resumes were new then. A lot of them were just coming in over the transom. But you look at resumes and say, no. Okay, I'll talk to this person. Talk to him? No. And were there questions on?
And then just kind of the other side, because since this is mostly from the management side,
Yeah.
and this week is the STEM